In this lecture segment, we'll finally finish the walkthrough of Mastermind's target function. The next code for discussion is the loop to select a random model pattern on lines 21 through 24 here. We'll look at all those care code functions in a moment, but first let's just discuss JavaScript arrays. The loop sets elements of the array model to hold random one-character strings that are in the allowed range, capital A to params.maxchar. And it sets elements 0 through params length -1, as you can see. But I said earlier on line 9 up here that we initialized model to be an empty array. So how can we then index it from 0 to 3 down in our example here? We can do this because JavaScript doesn't have arrays. Model is actually an object with a bit of special performance added. Let's call it an array object. So can an object act like an array? Yeah, in a sense. Consider the code that is in the transcript, in which I'll copy over here as well, along with a little picture of our model object. An object can have fields tagged by any string, and that includes strings that look like numbers, as in the example here. Though, to be sure, those index values are strings, they're not numbers. Now, if you squint hard enough, that makes model look like an array. You get something like this. So it's an array, sort of. It would look more like an array if we could index it with actual numbers. So let's see here. Take away the quotes. That looks better. And in fact, we can. A string, not a number, is expected when we index an object. But as we'll see when we discuss JS elemental data in more detail, JS readily converts other types into strings. So it will cheerfully convert our 0 number into a string 0, and then use it to index model, and we'll get the same result. So model's looking more and more like an array here. And it does have the advantage, if you want to call it that, of having no limits on the index range, nor any restriction on the type of element either. We can make it as big as we like and put any type we want at different indexes. They don't even have to all be the same type. So maybe I'll do this instead, adding a 42 at element 1 billion. Now, any good OO array object does have a length property, giving the number of elements, so you can know where it ends. Java's arrays, for instance, have such a property, so that in Java, array.length -1 is the highest index of array. Now, it turns out that this is one of the special performance items that I alluded to earlier. JS automatically adds a length property to each array object and updates it automatically to be the largest index that you've used, +1, which it should be for length, of course. This object now has a length of 1,000,001. And so we will expect a length property that is 1,000,001. And note, by the way, length, the value of length, is a number, not a string there. The 1,000,001 is a number, so that is as it should be. So does this mean that we just added 1 billion properties to model? No, as you can see just by looking at the diagram, if you check any intervening index, like maybe model 999999, it will have the value undefined, which is, of course, what it had when we first created model. If you want an index to have a value, you give it one. Otherwise, it stays undefined, even though it's technically within the array's index range. You know, once you have a big hammer, everything looks like a nail. And JavaScript's big hammer is the hash table object. We've seen that JS objects can be used as a lookup hash table with thousands of entries. And from the JS point of view, they also make nifty arrays if you index them right and add an automatically updated length property. So how do you get an object to behave this way with automatic length? By creating it with empty brackets, like we did on line 9 up here, and by other means that we'll get to in later lectures. The empty brackets is a near synonym for the curly braces that we've already discussed in prior in lecture questions. They just add that automated length property. And the resultant object, by the way, can still do all the normal object stuff as well. If I wanted to, I could add model.extra property equals some value. thus, and it'll add it to the array. And now your array has some normally named properties along with the number-like ones. So now that we have arrays in hand, let's look at the right-hand side of the line 22 to 23 assignment here. Starting in the middle of that expression at the red arrow, we begin with the string A and call its char code at method to retrieve the first, the index 0, character of the string. Now, you've probably noticed that the A is enclosed in single, not double quotes. Java and C programmers will be thinking perhaps, aha, that's a character constant. But, as I said earlier, JavaScript has no character variables. Single quotes are just an alternative to double quotes. You may enclose a string with either. So single quote A is an immediate synonym for double quote A. The char code at returns the numerical Unicode value of the character versus the one character string that we saw earlier returned by char at. JS requires a function like that to convert from character to number. And the number is a Unicode, by the way, not an ASCII code. So we're getting the Unicode for capital A and then adding a random value to it by calling math.random and multiplying by params.randrange, which is 6 in our case, the number of different possible character choices. And we come to our first in-lecture question here. Go look up math.random. And for the concrete case of a randrange of 6, what's the largest value that we might end up adding to the Unicode of A? Coming back from a pause there, math.random returns a random value, call it R, that is greater than or equal to 0 and strictly less than 1.0. So the largest value we could add is 5.99999. But the from char code function that we're about to pass this all to will truncate any fractional part. So in effect we can add at most 5 to get the Unicode of F. So the net result is that the expression computes a random Unicode from A to F, which we pass to string.fromCharCode to produce a one-character string that contains the corresponding letter. The string class, by the way, which is technically a constructor, as we'll see later, offers a suite of library functions for strings like math does for numbers. Let's digress a moment here and talk about string delimiters. Why would you want two ways to enclose strings, single and double quotes? Because you have to escape the enclosing characters if you want to include them, or the delimiting characters, I guess I should say, if you want to include them in the string itself. And it helps to have a choice in such cases. JS and other scripting languages meant for manipulating HTML strings do this so that you can have string content that includes double quotes without having to escape the double quotes. Looking just at the transcript here, you can see that where in Java or C you'd write an HTML string variable and have to escape out the double quotes within the HTML itself, that's pretty irritating, especially if you do a lot of it. By contrast, in JS, you just use single quotes to enclose the string, and then the double quotes that are content would not need escaping. If you want to see this idea carried to an extreme, you should check out Ruby, which has, gosh, I've forgotten, but perhaps a half dozen different choices for string delimiter characters. So moving on to our next topic here, let's look more closely at math.random. JS is notoriously full of dumb mistakes, and math.random is a good example. It uses the system time as a seed to initialize the random number computation, so you'll get a different value every time you call it. Well, that sounds fine, it's what you expect, until you try to write consistent tests, when you want the same random number sequence each time you run the code. Now, every other language lets you specify a particular seed to start the random number sequence, so you can make it repeatable. JS doesn't. It's completely missing from the library. We'll actually have to fix this later by replacing math.random with a random number generator of our own. And a final note, by the way, about the first two lines, which I've glossed over till now. Lines 1 and 2 are hacks that I added to accommodate the fact that the JSDB interpreter I'm using has println and readln functions that do what print and readLine do in the JS shell that is more of our standard and is used by IHS. I wanted to use the JS shell functions, so I simply did those assignments in advance. And here's an in-lecture question. Does that mean I copied a bunch of function code from one function to another, like from readLine to readLine? We're back from a pause there. No. All that's copied here is a reference. The variable print reference now points to println, for instance. And thus, when I use print, I'm effectively calling println. And the same is true for readLine and readLine.